This is my ENV2022 assessment video presentation on an environmental monitoring project in Canada. Now, the article I'm going to be discussing, the Harvard reference, is on the top of the slide as shown here. The title would be the Fuel Moisture Sensitivity to Temperature and Precipitation and its Climate Change Implications, and this is from the journal Climatic Change. And the data was received, accepted and published are there, as well as the target audience, I believe, will be reading this article. So the aim of this article is to examine the sensitivity of fuel moisture to changes in temperature and precipitation and explore the implications under a future climate. So in this case, fuel is any combustible material on the forest floor. Now, as it says, in methods, the article obtained weather data from 12 stations across Canada for the fire seasons during the 1971 to 2000 years. These fire seasons being the season from June the 1st to August the 31st. And then weather streams were created from the original data by varying the daily temperatures by 0 to plus 5 degrees in increments of 1 degree, and also varying the daily precipitation by minus 40 to plus 40%. Now, the fuel measured is based on three fuel moisture codes as shown in the image at the bottom. Fine fuel moisture code, which is basically fine dead surface fuels. Duff moisture code, which is the loosely compacted organic material on the forest floor. And the drought code, which is the deep compact organic soil layers. So these three fuel moisture codes are basically measuring how combustible materials are in the forest in Canada, based on temperature and climate. So the results of this article show that each of these fuel moisture codes increase with an increase in temperature, which basically means that they are drier. The fuel is going to be drier and therefore more combustible, and therefore an increase in precipitation is needed to compensate for this. So you can see at the bottom left, I'm looking at fine fuel moisture codes here. And this shows that as an increase in temperature, as the temperature goes up, so does the value for the fuel moisture code, which means it's going to be drier. And therefore, as you can see on the x-axis, increased precipitation change is needed to compensate for the change in temperature. Now, this was then combined with general circulation models. There were three models that were used here, one from France, one from the UK, and one from Canada. Now, these general circulation models are the most advanced tools currently available for stimulating the response of global climate systems to increasing greenhouse gas concentrations. Therefore, these can show that when there's increasing temperatures due to these greenhouse concentrations, these moisture codes are going to increase and there's going to be drier fuels. As you can see at the table at the bottom right of the article as well, you can see that as temperature increases, so does the percentage of days when the drought moisture code in this case is going to increase and therefore become drier. And again, precipitation change is needed to increase to compensate for these drier fuels. So the discussion and conclusion show that using general circulation models and the relationship between temperature, precipitation and fuel moisture, the results indicate that as temperature increases will lead to dry fuels in the future. Now, this has many significant impacts that can be used. Firstly, it shows that due to increased climate change in the future, using these general circulation models, there's going to be drier fuels and therefore a possibility of more forest fires occurring in Canada. And therefore, this can show fire watch and fire rescue teams in Canada that there are going to be more susceptible areas to combustion, and there's going to be increased fire risk. And this allows them hopefully to put more preventive measures in place, as an increase in global temperatures due to greenhouse gas concentrations will lead to an increase in potential fires. And so I think this extract from the article kind of sums up the most. It basically states that temperature increases in the future are going to lead to more fire activity due to these drier fuels. However, changes in other variables shown, such as humidity, winds and ignitions, are going to also influence the fire activity. And it states that the bottom line is that a warmer world will have more fire. And using these general circulation models combined with the data collected from each of these 12 sites, it shows that there is going to be a warmer world due to climate change. And this shows that there's going to be dry fuels, and therefore there's going to be a higher fire risk, which obviously, is going to put people at risk that are living in the forest, and also damage many, vital ecosystems. And so this, this article presents useful data in what's more susceptible to be damaged, and hopefully will allow, fire service watchers to make sure that vulnerable areas are looked after more.